Assalamualaikum and good day to everyone. My name is Farid Wajdi and my friend is Faris Firdaus. Today, both of us gonna present the video about ball bearings as instructed by our lecturer Puan Salmia Kasolang. I will start my video with the introduction and functions of ball bearing. There are many types of bearing, each used for different purposes. These include ball bearings, roller bearings, ball truss bearings, roller truss bearings, and taper roller truss bearings. In our investigation, we try to look at the ball bearing for supported with lubrication system. Ball bearings, as shown below, are probably the most common types of bearing. They are found in everything from inline skids to hard drives. These bearings can handle both radial and truss load and are usually found in application where the load is relatively small. In a ball bearing, the load is transmitted from the outer race to the ball and from the ball to the inner race. Since the ball is a spare, it only contacts the inner and outer race at a very small point, which help it spin very smoothly, but it also means that there is not very much contact area holding that load. So if the bearing is overloaded, the balls can deform or squish. Working principle. These bearings are characterized by balls or cylinders confined between outer and inner rings. The balls or rollers are usually spaced uniformly by a cage or separator. The rolling elements are the most important because they transmit the loads from the moving parts of the machine to the stationary support. Balls are uniformly spherical, but the roller may be straight, cylinders, or they may be barrel or cone shape or of other forms, depending upon the purpose of the design. The rings, called the races, supply smooth, hard, accurate surfaces for the balls or roller to roll on. Some types of ball and roller bearings are made without separators. In other type, there is only the inner or the outer ring, and the roller operates directly upon a suitable hardened and ground shaft or housing. This bearing may be classified by function into three groups: radial, truss, and angular contact bearings. Radial bearings are designed principally to carry a load in a direction perpendicular to the axis of rotation. However, some radial bearings, such as the deep groove bearing, are also capable of carrying a truss load, that is, a load parallel to the axis of rotation and tending to push the shaft in the axial direction. Some bearings, however, are designed to carry only truss load. Angular contact bearings are especially designed and manufactured to carry heavy truss loads and also radial loads. A unique feature of rolling element bearing is that their useful life is not determined by wear, but by fatigue of the operating surfaces under the repeated stresses of normal use. Fatigue failure, which occurs as a progressive flaking or shifting of the surfaces of the races and rolling elements, is accepted as the basic reason for the termination of the useful life of such a bearing. Operating condition of a ball bearing supported by a lubrication system. For bearing to operate properly, it needs to be lubricated. In most cases, the lubricant is based on elasto-hydrodynamic effect by oil or grease, but working at extreme temperature, dry lubricated bearings are also available. If the viscosity of lubricant is higher than recommended, lifespan of bearing increase roughly proportional to square root of viscosity. If the viscosity of the lubricant is lower than recommended, the lifespan of the bearing decreases, and by how much depends on which type of oil being used. For oil with EP, extreme pressure, additive, the lifespan is proportional to the square root of dynamic viscosity, just as with for to high viscosity, while for ordinary oil's lifespan is proportional to the square of the viscosity if a lower than recommended viscosity is used. Lubrication can be done with grease, which was his advantages that grease is normally held within the bearing, releasing the lubricant oil as it compressed by the balls. It provides a protective barrier for a bearing metal from the environment, but has disadvantages that this grease must be replaced periodically and maximum load of bearing decreases. Time between grease replacement decreases very strongly with diameter of bearing. For a 40 mm bearing, grease should be replaced every 5,000 working hours, while for a 100 mm bearing it should be replaced every 500 working hours. Lubrication can also be done with oil, which has the advantage of higher maximum load, but needs some way to keep in bearing. As it normally tends to run out of it, for oil lubrication it is recommended that for application where oil does not become warmer than 50 degrees Celsius, oil should be replaced once a year, while for application where oil does not become warmer than 100 degrees Celsius, oil should be replaced 4 times per year. For car engines, oil becomes 100 degrees Celsius, but the engine has an oil filter to continually improve oil quality. Therefore, the oil is usually changed less frequently than the oil in bearings. The bearing's steady-state temperature depends on load, rotational speed, and heat transfer property of the machine. Insufficient lubrication or improper mounting might cause the bearing temperature to rise rapidly. In such a case, suspend the machine operation and adopt an appropriate countermeasure. Effects of lubrication at ball bearing. The two main purposes of lubrication are to minimize friction and reduce wear inside bearing that might otherwise fail prematurely. Lubrication provides the following advantage. Number 1. Reduction of friction and wear. Number 2. Extension of fatigue life. Number 3. Dissipation of frictional heat and cooling. Number 4. Sealing and rust prevention. Selection of lubrication. Bearing lubrication methods are divided into two main categories: grease lubrication and oil lubrication. A lubrication method is adopted that matches the application conditions and application purpose in order to attain best performance from the bearing. Grease lubrication. Grease is a lubrication that is made from base oil, thickener, and additive. When selecting a grease, it is necessary to select a grease that is suitable to the bearing application condition. There are large differences in performance even between different brands of the same type of grease. Oil lubrication. There are several different oil lubrication methods: oil bath, drip feed, splash, circulating, jet, oil mist, and oil air. Oil lubrication methods are more suitable for higher speed and higher temperature application than are grease lubrication methods. Oil lubrication is especially effective in the case where it is necessary to dissipate heat to the exterior. Be sure to select a lubricating oil that has suitable viscosity of the bearing operating temperature. Bearing handling and maintenance. Precaution for handling. Since rolling bearings are high-precision machine parts, they must be handled carefully. Even if high-quality bearings are used, their expected life and performance cannot be attained if they are used improperly. The main precaution to be observed is follow. Number 1. Keep the bearings and surrounding clean. Thus, number 2. Handle with care. Number 3. Use proper tools. And number 4. Protect bearing from corrosion. That's all for the video of ball bearing. I hope you guys enjoy the video. Thank you and have a good day.